Welcome to part 2 of homework help from 9.1 Simplifying Radicals. If you are watching this video, then you struggled with 17 through 25 on the homework, which means you were really struggling with combining multiple radicals into a single radical and then simplifying. So with 17 through 25, just like we did on the notes yesterday, when you have multiple radicals being multiplied together, all we have to do is multiply my coefficients, so the numbers on the outside, with each other, and then multiply my radicands together, so again those are the numbers underneath my radical, and then simplify as we did on problems 5 through 8. So looking at number 17 first, square root of 3 times the square root of 6. We don't have any coefficients on the outside, so we don't have to worry about that. All we have to do is combine my radicands. So 3 times 6 makes it the square root of 18. And then we simplify the square root of 18 as far as we can. Again, I choose method 1 for most of my simplifications. So I'm looking for what perfect square goes into 18. In this case, the biggest perfect square that goes into 18 is 9. So I'm going to write this as square root of 9 times the square root of 2. Well, the square root of 9 is just 3. So 3 root 2 is my final simplification. With number 18, now we have 2 as a coefficient, so it stays outside. 12 and 2 are my two radicands, 12 times 2 being 24. And then again, I'm going to simplify as we did before. My coefficient stays outside. 24 can be split up into the square root of 4 times the square root of 6. So if the square root of 4 becomes 2, 2 times 2 is 4 times the square root of 6. For number 19, now I have coefficients on both, so I have to multiply 100 times 2 for my new coefficient, which is 200. My radicands get multiplied together. 5 times 6 gives me the square root of 30. And now I just have to check, do any perfect squares go into 30? So again, when we're doing this, start with the thing that's closest to it and check to see if it's a factor of it. So the closest perfect square would be 25. 25 does not go into 30. Neither does 16, 9, or 4. And those are all of my perfect squares less than 30. So since none of those go into 30, it's completely simplified. On number 20, now we have one term that's just a coefficient, 8, times 3 root 2. So outsides get multiplied together. 3 times 8 is 24. And my radical is left as it was. For 21, now we have 3 terms being multiplied together. But outsides still get multiplied together, insides also. So 3 times 9 times 4 is 108, and that's outside of my radical. 6 times 2 times 10 is 120, and then I'm going to split up 120 into perfect squares. Even though it's a pretty big number, the biggest perfect square that goes into it is 4. And then times the square root of 30. Well, square root of 4 is just 2. So 2 times 108 is 216. And as we saw in number 19, the square root of 30 cannot be simplified down any further. So our final answer is 216 root 30. For number 22, we have 2 different options. We can multiply straight away and then simplify. But here, I'm actually going to simplify this first because I recognize 121 is 11 squared. So instead of multiplying my 2 radicals together first, I am allowed to simplify each one individually and then combine them together. The reason I do this, again, is because I saw that 121 is a perfect square. So 121 is just 11. Which means I've really got the square root of 11 from my first term times 44 from my second term. So completely simplified is 44 root 11. Getting to my bottom row. A little more complicated because now I've got coefficients and radicands that have variables as their terms, but my process is still the same. My coefficients are x and 23 for both terms, so x times x is an x squared. Underneath my radical, 5 times 3 is 15. X times x, again, is x squared. So now, looking to simplify, x squared, I've got one pair of x's. So one is going to sacrifice to save the other. So now I had x squared originally outside. If I have one more x to that, now I've got x cubed. And my square root of 15 does not change. So x cubed root 15. For 24, again, I've got the option to whether I want to simplify first or combine them together and then simplify. Z squared I can recognize since it's got one pair. One is going to sacrifice to save the other, so my z is going to come outside of my radical. My x and my y, they've got no partners, no buddies, so I have to leave them underneath the radical. If I combine them together, z is outside, x and y are still inside. All right, for my final problem, again, I've got 3 being multiplied together. 2 times 4 times 6 is 48. 3 times 5 times 7 is 105. So then you just have to check all of the numbers smaller than 105 that are perfect squares if they are factors of them. However, whether you check it that way, by dividing by perfect squares, or if you recognize 3, 5, and 7 are already prime numbers, all 3 of them are, they're not going to have anything in common, so even after you combine them, they're still going to be prime, relatively prime. So whether you check it that way or use your prime number knowledge to recognize that 105 has no perfect squares less than it, we know that that's going to be simplified down as far as possible.